Hi, in this video we will do some examples for this IJK notation. What we learned was that we can write vectors in two forms. One, the triple or the pair ordered pair form, which you choose the components, first component, second component, third component. And in the IJK notation, the second alternative form, the coefficient of I is basically the first component, coefficient of J is the second component, and coefficient of K is the third component. So here I'll do some vector operations for the vectors written in terms of IJK. Let's start with the first one, 2I minus 3J minus K. Well, let's just write it in the triple form. Always the coefficient of I is the first component, coefficient of J is the second one, and the K, the coefficient, is the third one. How about this one here? We have the scalar multiplication and the subtraction. What we can do here is that, well, just go ahead and do everything in IJK form. Take them as variables. So here I will have distribute 2 over the bracket. So 2I plus 2J minus 6K. Then minus, we can do this thing, plus J minus 2K. And then, as you can see, put all i's together. There's 2I here. There are these two pieces of J, which add up to 3J. And then these two will give us negative 8K. When you write only one, the expression as linear combination of 1I, 1J, and 1K, then pick the coefficient of I. That's the first coordinate. Coefficient of J is the second component, and the coefficient of K is the third component. Well, here we are supposed to find the length of this vector. Okay, then let's just write it first in the component form. The coefficient of I is 2, that's first component. There is no J. That means that the coefficient of J is 0. That means that second component is 0. And the third component is the coefficient of K, which is negative 1. Well, if someone gives you the vector with components, to find the length, you need to square each component and then add them and then find the square root. This is 4 plus 0 plus 1, which is root 5. This fourth example is, well, let's just do first the operation here. Multiply 3 inside. This is 3I minus 3J, then minus 2I plus J, and minus 2K. And well, as a result, there are 2 i's here. 3 minus 2, that is 1I. J's, there is negative 3 plus J, this is negative 2J. And then K is negative 2K. Okay, so this now we can write it as components. The coefficient of I is 1. Coefficient of J is negative 2. Coefficient of K is negative 2. And when you write that in the triple form, we know that to find the length, we have to square each component and then add them and then find the square root. This gives us square root of 1 plus 4 plus 4, which is the square root of 9, and that is 3. So those are just different operations, vector operations, and we did everything in terms of I, J, K, and then final result. Okay, example 2 is express a vector which is equivalent to directed line segment from P to Q. Remember, such vector is has the components that you get from the subtraction of the coordinates of the second or end point here Q from the coordinates of the first or starting point. Here, this is negative 1 minus 1 and 3 minus 2. So the vector which is equivalent to the PQ direct line segment is negative 2 and 1. And when you have this thing, you know how to write it in IJK notation. The first coefficient, the first component is going to be the coefficient of I. The second component is going to be coefficient of K. Sorry, in this case, J, not K. Just J. When we work with vectors in R2, we only have I and J. The first component will go to the coefficient of I. The second component will go to the coefficient of J. Okay, how about this one? The U we have here is endpoint, the coordinates of endpoint minus the starting point. 3 minus 0, negative 2 minus negative 1, and negative 1 minus 4. So this is 3, negative 1, and then negative 5. While the recipe to turn it to IJK notation, first coordinates times I, second coordinates times J, the third coordinates times K. In other words, we have 3I minus J minus 5K. So these were examples in which we did work with IJK notation. You have to be able to apply all the operation we will learn here from this point on, or we have learned before, in terms of IJK.